All right, here we go with part 2 of our lesson today, and we're going to be learning how to find the derivatives of inverse trig functions. But first of all, let's take a minute to review what the inverse trig functions are. So I'm just going to go over a couple of them. So back to basics here. Let's say we have our sine graph. Looks like this. And then the inverse would be the graph we get if we reflect this across the line y equals x. Well, what you would get for that would look kind of like this. And I didn't make these to scale really. So the problem is that this second graph here would fail the vertical line test and not be a function. So what we do is we just take a piece of it that would pass the vertical line test, and that's the piece we use for the inverse sine graph. Now, that piece corresponds to this piece on the regular sine graph, which goes from an x value of negative pi over 2 to positive pi over 2, and from a y value of negative 1 to positive 1. So that tells us that our inverse sine graph goes from an x value of negative 1 to 1, and from a y value of negative pi over 2 to pi over 2. Now you can use this process to find the inverse trig function of any of the 6 trig functions. We're not going to be looking at them all, but just inverse sine and inverse tangent. So that one was the sine graph and the inverse sine. Remember, inverse is that little negative 1 symbol. It's not an exponent, it's just the symbol for inverse, and it's equivalent to saying arc sine or inverse sine in this way. Now, what if we have a tangent graph? So we have all these curves that do something like this with vertical asymptotes in between. And if we were to take that and reflect it across y equals x, you would have something like this with horizontal asymptotes in between. So again, we don't have a function, so what we do is we just take one piece that does pass the vertical and horizontal line tests. So the piece that we use from the original function is this, and when you invert it, you get this. Okay, so the x values on the original function were negative pi over 2 to pi over 2. So those are going to be the y values on the inverse. And then the range of the original function was all real numbers, so the domain of the inverse is going to be all real numbers. Okay, we're really not going to be spending much time looking at these graphically as we do the calculus. I just wanted to remind you of kind of what we're talking about when we talk about inverse trig. So what we're going to do is find the derivative of the inverse sine function and find the derivative of the inverse tangent function. So we're not doing inverse cosine, we're not doing inverse secant, cosecant, or cotangent. They do all have derivatives, but these are the basic two that we're going to cover. These are all you will need for this class. So just like you saw in the first video, when I found the derivative of the logarithmic function, the first thing I did was to take this equation and rearrange it. So what we can do to both sides is take the sine of both sides, because sine is going to cancel with inverse sine, and that's going to give us that's going to give us sine of y equals x. And then we're going to implicitly differentiate, so the derivative of sine y cosine y times the derivative of the inside y prime equals the derivative of x1. So we're taking the derivative with respect to x. Then we isolate y prime, and then what I would like to do is find a way to substitute something else for this, because I would like it to just be a derivative in terms of x. Okay, so to find something to substitute, what we do is we go back to that step that says the sine of y equals x, and we picture this with a reference triangle. So this would be angle y. The sine is x, so we can put x over 1 for opposite over hypotenuse. And then if we use the Pythagorean theorem, for the other side we get the square root of 1 minus x squared. So based on that, we can find the cosine of y. So the cosine of y is going to be adjacent over hypotenuse. square root of 1 minus x squared over 1. So we don't need to write the over 1 part. So the cosine of y is the square root of 1 minus x squared. Okay, so what this is telling us then, in summary, is that the derivative of the inverse sine of x with respect to x is 1 over the square root of 1 minus x squared. Now that we know that, you don't go through that whole process that you just saw me do. You just use this new rule. Okay, so make sure you have that new rule clear in your notes. And then we'll combine it with our other rules. So let's do some examples. Number 8, find the derivative of y equals inverse sine of 2x. Okay, so we're going to need to use the chain rule because we have 2x on the inside. So the derivative is, what was the derivative of inverse sine? It was 1 over the square root of 1 minus x squared, but this time we don't have x, we have 2x. So the square root of 1 minus 2x squared, and then we multiply by the derivative of the inside, so we're multiplying by 2. And then to simplify the answer, we can put the 2 in the numerator, and then we can simplify our radical, 1 minus 4x squared. Okay, number 9, same idea as number 8, but we have an inside function of e to the x. So the inverse sine function's derivative is 1 over the square root of 1 minus whatever that is, squared, times the derivative of that thing, that inside thing. And then to simplify this one, just keep in mind that when you have a power to a power, you multiply them. So on the bottom we have the square root of 1 minus e to the 2x, because we can multiply the x and the squared, or the x and the 2. Okay, in our third example here, we have a product. So we're going to use the product rule. So we have the first times the derivative of the second plus the second times the derivative of the first. And there's not a whole lot we can do to simplify that, but we can combine these first two parts into a fraction. And then it probably looks better to put the 2x before the inverse sine of x. All right. So let's do the same kind of thing for inverse tangent. So that means I'm going to take the tangent of both sides of the equation as I derive the rule here. The tangent of the right is going to cancel the inverse tangent. Then I'm going to use implicit differentiation. The derivative of tangent is secant squared. So we have secant squared y times the derivative of y, which is y prime, equals the derivative of x, which is 1. Isolate the y prime. And then find a way to substitute to get rid of secant squared y. So our substitution is going to come from that. The tangent of y is x, which could be thought of as x over 1. So here's angle y. Let's put x on the opposite, 1 on the adjacent. And then if you use the Pythagorean theorem, for the hypotenuse, you get the square root of 1 plus x squared. So once you have that, you can find the secant of y, which would be the hypotenuse over the adjacent, and then you can square it, and you just have 1 plus x squared. So that's going to go into our derivative. So y prime is 1 over 1 plus x squared, and you can write that as x squared plus 1 instead if you like that better. So what that's telling us is that the derivative of the inverse tangent function with respect to x is 1 over 1 plus x squared. So again, you want to memorize that and make it stand out in your notes. Okay, so let's do a couple of examples of that. All right, using the chain rule here with an x squared on the inside, we have the derivative of inverse tangent is 1 over 1 plus whatever is there squared. So it's not just an x this time, it's an x squared that we square, times the derivative of x squared, which would be 2x. So then we can rewrite that as 2x over 1 plus x to the 4th power. Same idea on the next one with a different inside, and this different inside has 2 layers. The outer layer is the square root function and the inner layer is the 2x function. So this is a chain rule with 3 layers. So the inverse tangent derivative would be 1 over 1 plus whatever's inside it squared, times the derivative of the square root function. So think of that as the 1/2 power. bring down the 1/2 and raise 2x to the negative 1/2 times the derivative of the inside, so the derivative of 2x would be 2. So let's simplify that. We can cancel the 1/2 and the 2. And we can simplify this little radical that's squared and make that 1 over 1 plus 2x. And then, because we have a negative exponent, we can move that to the bottom, and because of the 1/2 power, let's think of it as a square root. So then if we want to write that all as one fraction, we have 1 over square root 2x times the quantity 1 plus 2x. And, excuse me, finally, the last one is also a chain rule, but the outer function is not the inverse tangent function this time. The outer function is the squaring function. So the derivative of the outside, we bring down the 2, and we raise our function to the first. Then we multiply by the derivative of the inside, so the derivative of the inverse tangent function is 1 plus x squared. And then, I suppose we can just write it all as one fraction. Not really anything else to do. Okay, so there we have it. That was a lot today, but that pretty much takes us to the end of differentiation techniques. So that's a great feeling, I think. So here you have a few problems on logarithmic functions and a few problems on inverse trig functions. Thanks, everybody.